Hello, today we are covering lesson 1.1. So you'll see our objectives are students will identify, name, and model points, lines, and planes, and students will identify the intersections of lines and planes. Now these videos will be shortened versions of what we did in class, but you'll still get to see at least one example of every kind. So our undefined terms here, you can pause it, read through them. We will go through what these are today. So a long time ago, this guy named Euclid came up with the idea of geometry. So he started out with the idea of having a point, line, and plane and only using a compass and a straight edge with no sort of markings on it to create everything in geometry, our theorems, our postulates, everything we'll learn about this year. So we're starting where he started, and we will go through how he thought through things. So the first thing is a point. A point is a location. It has neither shape nor size. So even when we draw it out in person, we see it has a shape and size. In context, it actually does not, which that's hard to think about. So we give it a shape when we draw it. Specifically here, we have points named with a capital letter. In this case, you would name this point here point A. Make sure to write out the word point in front of your capital letter. A line is made up of points that it has no thickness or width. So similarly to the point, we have to draw it with thickness and width, but really it does not. There's exactly one line through any 2 points. So this is the only line that you can make for P and Q. Okay, any other way to connect them would not be a line. Now to name a point, the letters representing 2 points on the line, so either line PQ or PQ with a line over it, or the lowercase scripted letter or fancy looking letter. So these are the different ways you can name a line. And a plane, a plane is a flat surface made up of points that extends infinitely in all directions. So this plane extends all the way to the right, all the way to the left, all the way to the bottom, and all the way to the top. It covers everything, all the way up here, all the way down here. Even further, even off the page. It's infinite. Lines are similar. This line, because there's arrows, would continue to extend on both sides forever. Anyway, there is exactly one plane through any 3 points. So in this case, BDC, this plane is through those 3 points. But those points cannot be on the same line. So if we had 3 points here, all connected, this is not a plane. These are collinear points. To name a plane, you can name it by a capital script letter with the word plane in front of it, or by the 3 letters naming the points that are on the plane but not on the same line. So in this case, we can name it plane K. You could also name it plane BCD or plane CDB plus 4 other different versions. Those are all correct ways to name that plane. So you'll notice you name a point with 1 letter, a line with 2 points, and a plane with 3 points, or a line with lowercase script, or a plane with an uppercase script. So we're going to use what we know. Use the figure to name a line containing the point K. So there's a couple different names we can have for this. We can have line with a lowercase scripted a. We could also have line JL or line JK. Those are just 3 options of quite a few. There's others. All right. We also, for the next one, want to use the figure to name a plane containing point L. So the plane, we can name in a couple ways. We can name it plane. Notice how I'm putting the word plane in front of it. Plane with a scripted B. We can name it plane JML. I do want to point out we cannot name it plane JKL. Those 3 points are on the same line. So we want to name it something like JML instead. So we already did a line example. If you want to pause this and try it on your own, you can. I'm going to keep going to this one. We did do a plane example, but I do want to explain a little further. Use the figure to name a plane containing point Z. So we cannot use choice A because XY does not have 3 points so it's not naming a plane. Plane C is actually a line. And plane XQY are collinear points. So these can't name a plane. That leaves us with our last choice, plane P. So we have a capital scripted P is how we can name that plane. Okay, so there's some reasons why those ones don't work and what you need to pay attention for. These ones will go pretty fast. If we have a patio that's 10 foot by 12 foot, this is just a plane. So we're looking if it is a point, line, or plane. So this shape would be a plane. A button on a table, depends on what we're talking about. The button, I would consider that a point. While the table, I would consider that a plane. I'll let you go ahead and pause and think about these next two. All right, this next one, we are going to go ahead and draw out what it says. So we're going to draw and label a figure for the following situation. Plane R, which is already drawn for us, contains lines A, B, but let's wait, not draw them yet, and D, E, which intersect at point P. So we have to have these two lines specifically intersecting at a point called point P. So I'm going to go ahead, point P, label it, they intersect there, and then label my lines A and B, and then D, E. And there's another thing, we have to add point C on plane R, so that is not collinear with the other lines. So C can be anywhere else. Next, we're going to draw and label a figure for the following situation. QR is on a coordinate plane, so we plot Q, -2, 4, and we plot R, +4, -4. Make sure to draw that in. And then add T so that it is collinear with these points. So that T could go anywhere on that line as long as it's on the same line. So it's a good idea now, I would say, to go ahead and write out what collinear is. I just think about things sharing the same line or on the same line. And coplanar means they share the same plane or are on the same plane. Okay? I'll let you guys look at these next two. Pause. Figure them out. Right, when it gets down to it, for this one, we are left with B. This one doesn't work because line A goes through the plane. It's not on the plane. This one doesn't work because F is the intersecting point, not Z. And this one doesn't work because F is on the line and it needs to be not collinear. Okay, for this slide, how many planes appear in the figure? We for sure see one plane. Plane S. There actually is another plane. We can name it plane ADC. It's like we had two pieces of paper, one standing up and one laying on a desk. ADC goes through plane S, meaning we have two planes. Now on your homework in the book, there'll be a question like this. There will be many different planes if we were to do it like this. So I only want you to consider the ones that are shaded and labeled. It says in the book which planes are labeled. So any planes that have a label such as plane S will be your solution for that. 3 points that are on the same line, collinear. That would be points A, B, and D. Put commas in between. Are these points coplanar? They are coplanar for the plane that we created, that's there. But they are not coplanar on plane S. A is above the plane and D is below it. These guys, DB, because lines extend forever, and CA, they intersect at point A. This one will also be two planes. Again, we have plane T, and we have plane, we'll call it ABX, but really it covers all of this space. ABX is going through plane T. You can go ahead and take a second look at this one. There's actually 3 sets of collinear line or points, but only one correct one is included, and that would be AXZ. Our XOR coplanar, they are on plane T, but we can't use those to name plane T because they are collinear. They're also collinear in plane AXB, but we couldn't use those points to name AXB as well. Okay? So yes, they are coplanar, but can't be used to name. And then when can these intersect? BN would intersect XO at point R. Now, I do want to take a sec. This next slide is pretty important because these things will be on the test. If we have two planes, they intersect in a line. If you look up here at this guy, this plane intersects plane T at this line. So unless they are the same plane, they intersect in a line. Two lines intersect in a point. If you think about two lines crossing, they cross at a point, unless they are the same line, in which case they intersect in a line. And if we have a plane and a line, these can intersect either at a point if the line goes through the plane, or in a line if the line is on the plane. So through, at a point, on the plane, at a line. Alrighty, now you can go ahead and go to the homework list. You'll see what homework we have for 1.1. And then I will teach you how to turn that in on Canvas. Have a great evening.